Welcome to Module 6, Part 3. In this module, we talked about the different concepts and procedures related to the whole numbers that you should emphasize within intensive intervention. Now remember, you might not be using these concepts and procedures all the time, but for many of you, when you are teaching about whole numbers, you're going to want to rely on thinking about teaching those concepts and procedures in the ways that we discussed. So in this part, we're going to actually look at what does intensive intervention look like when teachers are teaching whole number concepts. So we're going to kind of start to combine many of the things that we've worked on in previous modules. So our objective here is for you to learn how concepts and procedures are practiced within intensive intervention. And we're going to be utilizing evidence-based practices, and I'm going to try to talk about these things as we watch them. So where are we with our DBI diagram? We're still focused on these orange components. So where we've got our instructional platform and where we've made our adaptation. Whole number content might be the focus of the instructional platform, and then it could also be the focus when we've done an adaptation. It also might be your adaptation might be to increase the amount of whole number concepts and procedures that you include within intensive intervention. So remember, when I'm talking about that instructional platform, that's our jumping off point. So that's where we are. We're right here. We've developed our instructional platform. We're focusing on whole number concepts and procedures, and we're jumping off, and we're going to use different types of evidence-based practices to both deliver the instruction and strategies that should be embedded within the instruction. All right, I changed clothes super quick to talk just about this slide because we had an audio problem with it the last time I recorded. So in this module, we are going to be thinking about how whole number content looks within intensive intervention. And we're going to focus on those 6 important components of intensive intervention. So I want us to be thinking about explicit instruction. So what does the modeling look like? What does the practice look like? Are multiple representations used by the teacher and by the tutor? What does the language sound like from the tutor, and how is that language communicated with to the student? And then, are there fluency building activities placed into the intensive intervention? Is problem solving instruction an important part of the intensive intervention? And is there a motivational component in play? So these 3 at the top deal with the delivery of the instruction, and these 3 down here are strategies that should be embedded within intensive intervention. What we're going to do is we're going to watch intensive intervention. And I'm going to be on the side kind of making some notes that we can debrief after we watch the video. But as this video plays, I'm going to point like, oh, when I see an instant of concise language, or when I see an instance of multiple representations, or when we see the tutor using explicit instruction. So I'll introduce you to this tutor. This is our intensive intervention tutor, Suzanne, and she is working with a student named Jerem. And they are going to work on the concepts around multiplication. So what does it mean to multiply? We'll go ahead and get the video started, and I'll point to these parts as we see them.
Good. Today, we're going to work on some multiplication facts, okay? This is important because when you're working word problems, you'll know what multiplication means and how to solve multiplication. Okay? All right, let's look at this. Let's look at problem A. This says 3 times 2 equals blank. What does it say?
3 times 2 equals blank.
That's right. And when we look at this, we can say 3 groups of 2 is the same as blank. Okay? So we're going to make some groups of 2. Can you make groups of 2 with these? That's one group of 2. How many groups do we need?
3.
3. We need 3 groups of 2. 2, 3. Okay, now we have 3 groups of 2. 3 times 2 is the same as, how many blocks do we have there?
Well, we have 3 groups.
So let's count them. 1, 2, 3, 4, 5, 6. So 3 groups of 2 is how many?
6.
Good. Can you write your 6 here? try that again. Now, read that one to me.
4 times 3 equals blank.
Very nice. So now we have 4 groups of 3 is the same as what? So how many are going to be in each group?
4.
We're going to make groups of 3. Can you make groups of 3? There's one group of 3. How many groups of 3 do you need to make?
4.
That's one group of 3. Awesome. 2 groups of 3. 3 groups of 3. Okay, now do we have 4 groups of 3?
Yes.
Awesome. Let's count how many blocks you have. 1, 2,
3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Awesome. Can you write a 12 in there? Great job. Now, I want to see if you can do that last one by yourself. It says 2 groups of 5 equals. Can you make 2 groups of 5? Awesome. There's one group. Awesome. Now you have 2 groups of 5. Let's count how many squares you have there.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Awesome. 2 groups of 5 is the same as 10. Okay, we're going to look at multiplication a little differently now.
All right, so that was the beginning of a lesson where Suzanne was working on the concepts of multiplication with Jerem. So I'm going to go to the next slide and do a little bit of a debrief from what we saw there. So the first thing I want to write over here is about the explicit instruction that Suzanne did. So our first part of explicit instruction is to have some modeling. So when we saw Suzanne do the modeling, she had a clear explanation. I think the first problem they did, I wrote it down, it was 3 groups of 2. So she modeled and she had a set of clear steps about how to use the manipulatives to solve that problem 3 times 2. She also had a really nice attention to concise language. Notice how she described 3 times 2 as 3 groups of 2, and she consistently used that language throughout the lesson. Whenever she was talking about multiplication, it was always groups of. So her modeling was very nice. She modeled, and she just did one problem. She showed the steps to solve that problem, and while she was doing that, she had concise language. Now, the other part of explicit instruction is practice. Now, they did guided practice, and the guided practice, Suzanne did not do the problem with Jerem, but she was really working with him step by step as he solved the next problem. Notice she did the same thing that I noted on another intensive intervention tutor, Stephen, in another module, is that she gave a lot of quiet time while Jerem was solving the problem. So she asked him, well, how many groups do you need to make? And as he was making those groups, it's a little bit, takes a little bit of time, but she was giving him the time that he needed. And while that guided practice was going on, she was guiding him, asking him how many groups he needed, and then she always did review the problem when he solved it. And then the last problem that she did is she gave him an opportunity to try one on her own. In fact, she said, now you're going to try one on your own, or something pretty similar to that. And so that was the independent practice that Jerem was participating in. Now notice Suzanne wasn't over checking her cell phone or her email. Even during independent practice, she was still giving Jerem prompts as he worked through the problem. So we see that explicit instruction that we've talked about in a previous module in really good action here. Now remember, we can't do explicit instruction without having those supporting practices. So I'll write supporting right here. So the first thing about supporting practice is asking the right questions. Suzanne asked tons of questions. So she asked, I wrote down a few. She asked, what does it say? How many groups do you need? How are you going to do that? So she was asking that mix of high-level and low-level questions to Jerem. Another thing that Jerem was doing is that he was frequently responding. I would say, I don't have my stopwatch out now, but if I did have my stopwatch out, I would definitely say that Jerem was responding. I would say that Jerem was responding every 30 to 60 seconds. Now, we didn't see Suzanne have to provide any corrective feedback because Jerem was doing a nice job with this lesson, but we did see her provide lots of affirmative feedback. And so I'll just write affirmative feedback, great job, that's right, 3 times 2 is 6, or 3 groups of 2 is 6. Suzanne was doing a really nice job with that. So I want to focus a minute on the concepts and procedures, but I think it's really important to see how explicit instruction is used within a whole number lesson around multiplication concepts. And the final thing to supporting practice is it needs to be planned and organized. I don't think any of us would question that Suzanne had this lesson planned out. It was organized. She knew what problems she was going to solve. She had the manipulatives out on the table, and she had a small number of manipulatives. So she didn't throw an entire bin of Unifix cubes out there, but she had just enough cubes for Jerem to do his work. Now we saw explicit instruction, and you would see throughout the video I pointed to a few other things that are important to think about in terms of instructional delivery. The middle one was multiple representations. Jerem was using the Unifix cubes to show multiplication in a way where he was thinking about the groups of. And as I mentioned before, Suzanne was concise with her language. She was describing multiplication as having groups. She talked about, she was formal with her mathematical language, and she was precise and concise. Now, where we are in this module is talking about whole number concepts and procedures. So there were a few that Suzanne emphasized within this lesson. So in terms of concepts, we were focusing on the concepts. Let me start writing right there. We were focusing on the concepts of multiplication. And so she introduced the idea of multiplication. She explained why multiplication was important. In fact, so she's doing that explicit instruction goal, and here's why this is important. And she described multiplication as meaning groups of. Now, in our this module, part 1, we talked about that there's several ways to think about multiplication. The really introductory model of multiplication is thinking about groups of. So, and she had 3 times 2, or 3 groups of 2. So that means that she was visually showing 3 groups with 2 in each group. And then the student could count all, or if he wanted to, he could have skip counted to figure out the product, which would be 6. So the concept that she was working on here was multiplication. And she was explaining multiplication in those groups of, and she did it consistently using this explicit instruction. Now, this lesson wasn't as much about procedures, but there were some procedures that Suzanne was using. These aren't the procedures around computation or adding, subtracting, multiplying, and dividing that we've just talked about, but they are procedures that we do use in mathematics. So one of the procedures that I saw Suzanne use is counting. So she had a procedure for how to solve these problems. So she had a counting procedure. So to solve this, the student counted 1, 2, 3, 4, 5, 6. She also had a procedure of writing the answers. And she would do that, or the student would do that. And she also focused on the procedure of, I don't know how I want to write this, reviewing the answer. So when the student figured out that 3 times 2 is 6, Suzanne said, yes, that's right. 3 times 2 is 6, or 3 groups of 2 equals 6. This reviewing is a really important procedure in mathematics. And in fact, I would say that every time you're solving math problems, you always restate or review the answer. So you say, that's right, 3 groups of 2 equals 6. That's right, 100 minus 50 is 50. That's right, when we add 8 marbles, we end up with 16 marbles. So it really helps students understand what's going on in the problem. Now I just did a bunch of writing. We're now going to look at another video. Before we get to that, I will erase all of this. But in this video, we're going to see more of a procedure emphasized around whole numbers. All right, I erased all the notes from Suzanne's intensive intervention. Now I'm going to have you watch Jun Shou and do her intensive intervention. She's working with a student named Esri, and as you can see here, Esri is solving this problem. We actually saw this video, the first part of this video, in another module. She's solving the problem 204 minus 167. And that's a difficult problem because students have to regroup across 0, which often causes a lot of confusion and difficulty for students. So now we're going to see Jing Shou teach the procedures for solving a problem such as this. She's also going to combine that with concepts. So this is not strictly a procedural lesson, but it's also a conceptual lesson as well. Now, I'm not going to point to these this time, but as the video goes, I want you to see where explicit instruction is coming into play, and it should be everywhere, all right? I want you to see how multiple representations are being used, and here's a little clue as to what we might be doing there. And I also want you to pay attention to the concise language that's used within this video. So we're going to watch the whole thing, and then when we come back, we'll debrief to think about how were the concepts and procedures of whole numbers emphasized in this lesson.
I told you this problem is a little bit tricky, so that's all right. We're going to use the base 10 blocks to help us, all right? So have you ever used them before? Yes, good. So first, we're going to write hundreds, tens, and ones column here. Alright, so these little cubes are our ones. 1 cube represents
1.
good, and 1 rod represents 10. Good job. And 1 flat represents
100.
100. Good job. But I have a harder question for you. Do you know how many tens are there in 100?
10.
Good, because there are 10 groups of tens, right? Alright, so now first let's look at the number we start with. We start with what number?
200.
Good, 204. Sorry, 204. So can you tell me how many hundreds are there in 204?
2.
2. So how many flats do we need?
2.
2. Right. 1, 2, and I'm going to write 2 here. And how many tens do we need?
0.
0. So we don't need any rod here. Alright. So how many ones do we need?
4.
So can you count 4 cubes and put them in the ones column? Good. So what number did we show?
204.
Okay, so can you write 4 here? And we have 0 here, right? Can you write 0 here? So it's 204. Alright, so now we're going to do the subtraction. What number are we subtracting?
167.
Good, 167. And where do we want to start? We start with the ones place, right? So we have to subtract 7. And how many do we want to take away? 7, right? We have to take 7 away from 4. Can we do that? Can we take 7 away from 4? No. So what do you think we should do? Maybe we can exchange something for ones, right? But do we have any tens here to exchange? No. So maybe we have anything else to exchange? Do you think we can exchange the 100 into tens? Right. So let's count 10 rows here. 1. Do you remember we said how many tens are there in 100?
10.
10 tens. Good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can exchange 100 for 10 tens, right? So we exchanged 100 for 10 tens. Now, what are we going to do? We still only have 4 cubes, right? So we have to exchange 1 tens for how many ones?
10.
10 ones. 10 one. Okay. 5, 6, 7, 8, 9, 10. So we exchanged 1 rod for how many cubes?
10.
10. Okay, so can you tell me how many ones do we have now?
14.
14. Good. So we have 14 cubes here now. So do we have enough to subtract 7 now?
Yes.
Yes. All right. So let me write here 167 here first. And can you take 7 away from 14? All right, go ahead. All right, so we take away 7, and how many left?
7.
7. Good. So actually, yeah. So we take 7 away from 14. So now how many do we left?
7.
7. So can you write 7 here? Good. Right. So now we only have how many tens here?
9.
9. So can you take away 6 rows here? All right, can put here. So how many rows are left?
3.
So can you write 3 here? Good. So we have 100 here, and we have to subtract 100, right? So what are we going to do? We're going to take away 100, and how many left?
0.
0. All right. So we have 0 left, but actually we don't need to write 0 here, right? So our answer is
37.
37. Good. But let's check whether this answer is correct. So if this answer is correct, when we add 167 and 37, it would be equal to 204, right? So can you check the answer? So you're going to add 167 and 37. All right, so is our answer correct? Good.
All right, so Jing Shou did a really nice job with this lesson. I'm not going to point it out this time, but she used tons of explicit instruction. This was a lot of guided practice with the student. This was the part of that lesson. She was working with the student was frequently responding. She was frequently moving things around. Jing Shou was doing the writing, but then the student did the writing. Lots of nice explicit instruction going on there. We have the multiple representations, both the abstract form of mathematics, and here we have the concrete form of mathematics. I would almost always say we kind of have a representational thing here with our hundreds, tens, and ones column drawn on the table. And then she did a nice job with her concise use of language. One of the things that I thought was excellent is that she did not describe regrouping as borrowing. She described it as exchanging. So if an exchange of 10 ones for 110 or 110 for 10 ones and that type of thing. So really nice, consistent use of concise language. But why we watched this video here was to think about what were the concepts and procedures of whole numbers that Jingshou focused on. So I made some notes. I've got my notebook here. I'm going to write it down because I was watching the video just as you were watching the video. But in terms of concepts, well, the first thing that I saw that Jingshou emphasized was understanding base 10 and the base 10 blocks, and that these are represented by hundreds, tens, and ones. And she did a nice job of giving a student a visual for the place value, oops, I'll write tens there, the place value that goes with hundreds, tens, and ones. She did a nice job of talking about these as flats, rods. She did call those cubes. We talked about that in a previous module. That's okay if she uses that consistently. And she did a nice job of talking about exchanging. So I have 10 tens and 100. That was, I think, the example that she gave. And this exchanging, she was using the word exchanging, but she's talking about regrouping. But these are all conceptual ideas. So you have to understand our numbers in base 10, have to understand how numbers can be represented by hundreds, tens, and ones. And then she did a nice job, and this was throughout the lesson, of emphasizing the exchanging or the regrouping. Now, the thing that Jingshou did a lot on were the procedures here. So they were working on this subtraction problem. So I would just kind of put these out here. So she talked about first they're going to start with 204. So she wanted to show the, what is that in that number? Is it the minuend or subtrahend? It's the minuend. So she started with the minuend of 204. And then she had the student show the hundreds, tens, and ones, or as here she called them the flats, rods, and units. So getting this problem, or she didn't call them units, I called them units, she called them cubes. I'll go ahead, well, I want to write units because I feel like that's the more correct way to talk about those, and that's what will be in your memory. So then she did the procedure of showing these, and then they did the subtraction. So then, well, wait a minute. Yes, so then she talked about that they need to subtract 167. And the procedure of what did that entail, I'll kind of put that down here, is first they subtracted the ones. So now I, of course, subtracted the ones. And this is where there was a regrouping. So that's always good to check if you have to do that. And remember, she didn't call that regrouping. She called that exchanging. Means the same thing. Then Jingshou and Esri, they subtracted the tens and talked about a regrouping necessary there. And then finally, they subtracted the hundreds. So look at this procedure that Jingshou is teaching. It's quite detailed, and this is not the simplest of problems, but there's quite a bit going on here in terms of what she's thinking about in terms of the procedures. And then what I liked is that once they solved the problem, she reviewed the answer, and really importantly, Jingshou, the last thing she did is they checked their work. And how did they do that? They did it by using addition. And I'll kind of scoot in front of that so now you can see it just a little bit better. So the idea here was that if we're doing intensive intervention, and we're focused on, here it was computation for multi-digit numbers. We have both the concepts that we emphasize to the students, and then we have the procedures that we emphasize to the students. And Jingshou did a really nice job of doing this, all of these things. This was her instructional platform. It was teaching about computation. She emphasized both the concepts and the procedures that we've talked about earlier in this module, but then she employed things that we've talked about in previous modules. So using explicit instruction, using multiple representations, being concise with her language. So now that you've watched those videos, let's do workbook activity number 8. I want you to read this intensive intervention about computation, and I want you to identify the components and how they were used. And what components do I want you to identify? Explicit instruction, how it was used. Were multiple representations employed? Concise language, how was that used? And was fluency building a part of this intervention? Was problem-solving instruction a part of this intervention? And then what was the motivational component that was used? So I just want to point out a few things. So here is the lesson that you looked at. This is from a program that was developed at Vanderbilt University by Lynn Fuchs and her colleagues called MathWise. So you can see here we start on the lesson, and the first thing the students do is a set of math fact flashcards. Now if you go to the next page, it just says to follow the activity guide. They didn't end up writing out how to do the flashcards every day because at a point that just becomes automatic, but that's your fluency building activity. So there we see one of those components that should be in our instructional platform. There it is. Then as we start to read this lesson, here's what the student is working on. And you can see that what's in bold are what we would like the tutors to say. And this is all explicit instruction. Let's talk about counting up for addition and subtraction. So we're using formal language about adding and subtracting. Then you can see a question posed to the students. How do you count up? And then the student responds. So it's very explicit instruction going on quite a bit here. You will see that one of the things they introduce is an easier term for young students to say than subtrahend. They call that the minus number. Let me just go back. I see that word minus number here. So it's an introduction of mathematical vocabulary to help make the procedures for counting up just a little bit easier. So then here we talk about like the plus and minus signs. So another concise thing about vocabulary. This is all very explicit as the tutor is giving this information to the student and the student is responding there. And then they go into these combination blocks. So here we see an example of multiple representations. Here the students are showing different combinations of 5, so taking blocks, 5 blocks, putting them together in different combinations. So here showing 5 minus 0 or 5 plus 0. With the other combinations later on, students would see that like, oh, 2 plus 3 is 5, in the same way that 5 minus 3 is 2. Here's an example of different combinations that all relate to adding or subtracting with 0. But then we continue on with our explicit instruction. Students are doing procedural work where they're writing answers. They've also just with all these combinations focused on the conceptual. So you can see how all of these things start to pile together within that instructional platform for the student. And this is what we would use within intensive intervention. I'm going to go here. So that was all about single-digit computation. Then they do a lot of work on double-digit computation, talking about the signs that guide addition and subtraction. So it's getting into the procedural thing. Here they talk about computation. They are going to use a traditional algorithm in this lesson. You'd be welcome to use a partial strategy or another algorithm to add there. They also have a procedural strategy for drawing a line and how to separate the numbers within the place value columns within computation. So that's a helpful strategy there as well. I want to just get to a few things. So that's page 209 and 210. I know you read all of this, but we see just a lot of good explicit instruction about explaining how to add or subtract. And then when we finally get down here to, and I didn't include it, but it's in here. On this last page, there's a review, and that's where the motivational system is embedded within that. So if the student earned points throughout the lesson for being on task, then they get to color in little owls on a sheet. And then when they have a certain number of owls colored in, they get to pick up a small prize. But you can see that's what intensive intervention should look like or could look like. So when we're thinking about DBI with intensive intervention and we're focused on conceptual and procedural understanding of whole numbers, remember I want you to be explicit. The videos that we saw and the lesson that we just read, very explicit instruction. Everything that we saw and read used multiple representations. We also had a focus on using precise and concise math language. In the instruction or in the intervention that we read, we saw a fluency building activity. We didn't see any focuses on problem solving because I've just showed you like small clips of these interventions. But if we saw a 30-minute or a 25-minute intervention in all of those, you would have seen some practice on problem solving today. And then we also always want to include a motivation component when necessary. So now what you're going to do for this discussion board is I'd like you to make a video of yourself solving a multi-digit addition, subtraction, multiplication, or division problem using a non-standard algorithm. And I want you to share this video and your experience of doing this with your classmates so that they'll have new examples of how this can be taught and you'll probably have a new understanding of this topic. Good luck.